Hello everyone, I hope you all are fine. In the previous video, we learned about the matrices, its types and the properties. And if you haven't watched that video, I recommend you to please go and watch that video. In this video, we will be learning about the multiplication of matrix and its properties with different kinds of multiplication. Okay. Our first topic in this multiplication of matrix is multiplication with scalar values. How matrix operates when we multiply a scalar value to the matrix. Let's see through an example here. Let's take a matrix here with the random values 2, 3, 4, 1, 2, 4. Let this be matrix A. And let's suppose a scalar value 2. So how to multiply the scalar value 2 to the matrix A? The multiplication is simple like the normal mathematics, but as it is a matrix, so we have to multiply the scalar value to every element inside the matrix to get the desired result. Okay, so 2 4s are 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 1s are 2, 2 2s are 4, and 2 4s are 8. So this is how we can multiply a scalar value to the matrix. Okay, so this will be our multiplication result. And you can see that when we multiply the scalar value to the matrix, it does not put any impact on the order of the matrix. Okay, it does not have any effect on the order of the matrix. The order remains same, just the values becomes multiple of the scalar value. Okay, so you understand this term, the multiplication with scalar values? Let's move further to know the properties of scalar multiplication in different conditions. For that, assume two matrices A and B of same order m by n with the elements Aij of A matrix and Bij for B matrix. Assume K and L as scalar values. Okay, so here K into A plus B, A and B represent the matrix and K represent the scalar values like here. So how we can solve this? The scalar property does not impact on the order of the matrix, and we simply impose this scalar value inside the matrix to solve the problem. So simply it can be written as Ka plus Kb matrix. So the answer will be same in both the cases. Okay, this is the scalar property, scalar multiplication property. This Ka and Kb multiplication is similar like that we have done before. Ka as like this and Kb just matrix change and the process remains the same. Okay, so now done with this, let's go to next. We have two scalar values in addition and then a matrix in multiplication. How we can solve this? As per the matrix property, we can solve this as Ka plus La also, but the same. Both the cases the results will be same. Let's go further. Here we have third KL into A. So we can write this in different form also. Suppose we can write it as K into L into A. Here we have first multiply L scalar value into the matrix A, and then afterward the result we multiplied by K. So in both the cases the result will be same. Or we can also do this by just post L outside and K inside. So in all the three cases the results will be same. So scalar value does not impact the result if we change the position. Okay, let's go further. We have minus of K. So it simply can be written as minus of Ka. Okay, or we can say that k of minus a. In all the three cases, the results will be same. Let's go further. Next we have 1 into a. 1 is the scalar value and a is the matrix. So the answer we can write it as a only. Okay, no problem. In the next case, if we multiply minus of 1 to the matrix, it will come as minus of a. So you have seen that in the all 6 problems how the scalar value is operated with the matrix in different cases and how it gives the result. Okay, so next we are going to learn about the matrix multiplication. So let's go further now. For matrix multiplication, let's make a matrix A with values A11, A12, A21, A22. Here 1 1 represents the first element of first row and first column. Here 1 2 represents the element of first row and second column. 2 1 represents the element of second row, first column, and 2 2 represents the element of second row and second column. Okay, let's assume a second matrix B where elements are B11, B12, B21 and B22. Before multiplying any matrix, you need or you should be aware that to multiply any matrix, the condition should satisfy the number of columns, that is here 2 for a pre-multiplier should be equals to the number of rows of the post-multiplier, that is here 2. Okay, so for this, if we assume this as m by n, and for this if we assume this as p by q, then here n should be equals to p to perform the multiplication. So p should be equals to n to perform the multiplication. Okay, so how we can multiply this? A, B. We can multiply this by going by process step by step. I'll tell you. A11, we will go here by row first in the first pre-multiplier matrix, and here in the column we will go by column in the post-multiplier matrix. Okay, for multiplication. So for this value, first value, we will multiply A11 to the B11, say A11 into B11, and we'll add this A12 into this A21. We will add A12 and of B21, and this combined result will give us the first element of the A into B matrix. Okay, next the second element. So for that we will multiply this first row to the second column of the other matrix, that A11 into B12 plus A12 into B22, A12 into B22. This will give the second element of the A into B matrix. For third element, we will multiply A21 to the B11 and add A22 to the B21, A22 to the B21. And next, for the fourth and last element here, we will multiply A21 to B12, the second row, second column here. So A21 into B12 plus A22 into B22, A22 into B22. So this will give the result of A into B multiplication of the matrix. Okay, you can see from this result that the order of resultant matrix becomes the value of 2 of 2, that is m of q. Here we have A matrix of order 2 by 2 and B matrix of order 2 by 2. and the resultant matrix came same 2 by 2. So we can say that the resultant matrix will have the order of, if we have first pre-multiplier matrix as m by n and post-multiplier matrix as p by q, and we have this value same, the resultant matrix have the order of m by q. Okay, for example, if we have first matrix as of order 2 by 3 and second matrix of order 3 by 4, so the resultant matrix will have the order of 2 by 4. Okay, how 2 by 4 represents like this? We have 2 rows, 1, 2 and 4 columns, 1, 2, 3 and 4 columns. This will represent the 2 by 4 matrix. So let's go further. In the previous video, I have told you about the idempotent matrix, where the properties is if we multiply the same matrix, the result will come as the same itself. Then we will call it as idempotent matrix. And I showed you 2 examples of that. So let's verify these 2 examples. Okay, these are 2 examples: 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. Let's prove them. Okay, we have matrix A as 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3 in whole bracket. So this was the matrix given. Let's prove that. First we will find the left hand side, and then afterward we will compare this with the right hand side. Okay, so for left hand side, I'll add just a square. We can write this as a into a. Okay, so let's write this matrix as 2 minus 2 minus 4 minus 1 3 4 and 1 minus 2 minus 3. Write again 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. Now let's multiply. The result will given as a square. Okay, so I am writing here this. Okay, can you guess what will be the order of this multiplication result? Here for this matrix we have order as 3 by 3, and for this matrix we have order of 3 by 3. So the resultant matrix will be of order this 3 and this 3. Okay, so order will be 3 cross 3. Let's solve for that. First, for multiplication, first we go with the row, and for other matrix we'll go with the column. Okay, so 2 into 2 I can write as 4, minus 2 into minus 1 I can write it as plus 2, and minus 4 plus 1 I can write it as minus 4. Okay, for next element we'll go with 2 and minus 2. 2 into minus 2 will also give minus 4, minus 2 3 will give minus 6, minus 4 minus 2 will give plus 8. For next element we'll go with this is the third column. 2 into minus 4 will give minus 8, minus 2 plus 4 will give minus 8, and minus 4 minus 3 will give plus 12. In the next column, next row, minus 1 into 2, so which will give minus 2 plus 3 into minus 1, that is minus 3, and 4 into 1, that is plus 4. For next element we'll go with the same row and next column. Minus 1 into minus 2 will give plus 2, 3 into 3 will give 9, 4 into minus 2 will give minus 8. Okay, for the next element we will go with the same row and third column. So minus 1 into minus 4 will give plus 4, plus 3 into plus 4 will give plus 12, and plus 4 into minus 3 will give minus 12. For the next element we will go with the next third row and first column. So 1 into 2 will give 2, plus minus 2 into minus 1 will give plus 2, plus minus 3 into plus 1 will give minus 3. For the next element we will go with the same row and next column. 1 into minus 2 will give minus 2, minus 2 into 3 will give minus 6, minus 3 into minus 2 will give plus 6. For next element we will go with the same row and next third column. So 1 into minus 4 will give minus 4, plus minus 2 into 4 will give minus 8, and minus 3 into minus 3 will give plus 9. Okay, let's compute this result. We have first 4 minus 4 0 plus 2, so 2. So we'll write here as 2. Here 8 minus 4 4, minus 6 minus 2. So we'll write here minus 2. Next we have minus 8 minus 16 plus 12 minus 4. We'll write it as minus 4. Next we have 4 minus 2 plus 2 and minus 3 minus 1. So minus 1. Next we have 2, 9, 11 minus 8, that is plus 3. Next we have 4 plus 12, 16 minus 12, 4. Next we have 2 plus 2, 4 minus 3, 1. Next we have 6 minus 6 cancel, minus 2. Next we have 9 minus 8 plus 1 and minus 4 minus 3. Minus 3. Let's write down in the matrix form. Okay, so this is our LHS. 2 minus 2 minus 4 minus 1 3 4 and 1 minus 2 minus 3. Okay, let's see the RHS of our question. RHS has 2 minus 2 minus 4 minus 1 3 4 and 1 minus 2 minus 3. So write it down, or we can direct compare that. First element 2 is same, minus 2, second element same, minus 4 same, 1 minus 1 and 3 4 1 minus 2 minus 3. Oh, all the elements are same, so we can say that equals to RHS. Hence proved. Hence prove that this matrix A is an idempotent matrix. Okay, which follows A square equals to A. Next example I showed you was this 1 0 0 1. Let's say as A. Can we prove this also? So let's say A square will give as 1 0 0 1 into 1 0 0 1. The result will come as 1 into 1 1, 0 into 0 plus 0, 1 into 0 that is 0 plus 0 into 1 that is 0, 0 into 1 that is 0 plus 1 into 0 that is 0, 0 into 0 plus 0 and 1 into 1 plus 1. So after solving we will get 1 0 0 1. So that is same. So this example is also a idempotent matrix. Okay, hence proved. By doing these proofs, I showed you two things. First, the proof of idempotent matrix, and second, we gain the knowledge of multiplication, that how we can multiply the two matrices. Okay, so I hope you know or understand this process of multiplication. Let me give you a homework. There is a matrix value 5 minus 8 0, minus 5 minus 8 0, 3 5 0, 3 5 0, 1 2 minus 1, 1 2 minus 1. A. You have to check whether this matrix is idempotent matrix or involutory matrix or none of the two. Okay, you have to check whether this matrix A is idempotent matrix or involutory matrix. Okay, and if you don't know what involutory matrix is, you can watch the previous video where I have discussed about the involutory matrix. Okay, so I hope you understood the whole process of multiplication of matrix. If there's any doubt with this multiplication process, you can comment in the comment box and I'll be happy to answer these questions, your doubts. Okay, thank you.